Hi everyone! In this video, I'm going to continue with the example that I used for step 1 and step 2 of the Unit 4 project. So that's 5 samples from Utah, 5 samples from Spain, and 1 root for the tree, which is the original genome that was sequenced for COVID-19, for the coronavirus genome. What I'm going to do is I have already given you this example script to show you step 3 of the Unit 4 project on Canvas. I'm going to walk through each step of the code and just explain what it does and how you're going to change it for your individual tree that you downloaded from NCBI Virus. So the first thing we need to do is load the library ape. You may have already installed this on your computer, and so if you're working locally on your computer and not in our Studio Cloud, you probably won't have to reinstall it. But if you have not used ape before, you would go to Tools, Install Packages, because this is a tool that is not available from Bioconductor. It's available from CRAN. And we would type ape and install. I don't need to do that because I have already installed it, so I will simply load the library by running library ape. Now I'm ready to read in my tree. I've changed my tree name to be example.nwk. Yours will most likely be tree.nwk. It's a Newick file, and you're going to want to make sure that you have this file in your folder. So you can see I have a couple of different tree files here, but example.nwk is in my folder. So you can download my example, make sure the script runs, and then you can change it for your individual tree. So I'm going to load the tree, and we can see it loads as a new type of data. So this is not a data frame, it's a list. And each element of the list we can refer to with the $, sort of like a column in a data frame. And we have edge, edge length, number of nodes, tip label. And the reason to use a list is each of these elements, unlike a column in a data frame, is a different data type and a different length. So edge, there are 20 edges. There are 20 edge lengths. Number of nodes is just a single number because there are 10 different nodes in this tree. And the tip labels, there are 11 because there are 11 leaves to this tree. The tree that you set up using FluBlast will determine what the root is based on the order that you select them. So the first thing we need to do is we need to make sure that the root of the tree is the label and is the number and the tip of the tree for the reference genome. So we can do that in a couple different ways. The first thing that I'm going to do is on the console, I'm just going to type tip my tree $, tip.label, so I can see what all the labels are. And if I look at this list, I see the 10th label is this MT number, which means that the 9th label is the root of the tree, the reference genome. So since the 9th label is the reference genome, I'm going to run line 10 and reroute the tree so that the reference genome is the root of the tree. Everything is the same for the tip labels. We still have 11, but there are now only 9 nodes and only 19 edges and 19 edge lengths. So the tree has changed shape. We can plot this new tree, and we can see that now the reference genome is at the root of the tree, and we can add labels on the nodes so we can see how the tree connects with these 9 labels. We can also change the coloring of the tree. So we can make it so that the edges have different colors. I'm setting them all to gray to start, but you're welcome to change any individual edges when you're doing your final plot for your report. I'm also changing the color of the tips. And I've done some work ahead of time to figure out which number in the tip color will correspond to Utah, Spain, or the reference genome. Now, when I put this together, I will be able to have new labels that are color-coded, and you can see that this updated tree is a lot easier to read. So I can click zoom to see a bigger version of it, and I have a reference genome in black The Spain sequences are all in purple, and the Utah sequences are all in red. Now I want to look at other formats for the tree. I want to see if it's easier to read in a fan style or a radial style. The plot function that's built into R is unable to show those. So I'm going to use a new function called plot.phylo that's available in the 8 package. So when I run line 42, I can see the fan style. And this, I think, is a little bit easier to read. It shows the root as the reference, and we can see the relative distance. So we can tell right away that the Utah March 7 is the furthest sequence from the reference genome. We can also look at the radial style tree. This is a similar organization to the fan style tree. Instead of being circular, it comes out at sharp angles. But you can also see that there is a clustering of these Utahs, these 3 Utahs, a clustering of these 2 Spains, and those relationships are going to be something that we're able to visualize, but mathematically in the next part of the project when we calculate the distances for each of these leaves of the tree from the reference. So that's all you need to do for step 3 of the project. Load your individual tree, reroute the tree, and try out the different plot tools to see what visualization of the tree is best for your samples and your geographic regions that you've selected. I hope this video helps you move forward on the Unit 4 project.